Simplify each expression. Assume that all variables represent positive real numbers. There's two ways of doing this problem here. The first method is to recognize that 64 is equal to 8 times 8 because the cube root of 8 is equal to 2. So if the cube root of 8 is equal to 2 and the cube root of 8 is equal to 2, then you get 2 times 2 is equal to 4 and on the outside. If you look at this p, you can get one group out and you would have one left. So there's 4 p's. If you want them in groups of 3, you would get one group and then there's one that goes back in. And q to the 6, there's two groups of 3, so that would be q square. And then here's your little cube, which is your index. So your answer to this problem would be 4p to the first, q square, and then the cube root of p. If you can't recognize that the cube, or that 64 is equal to 8 times 8, the cubes inside of 64, you could do the prime factorization for 64. So we start with the smallest prime number, which is 2. 64 divided by 2 is equal to 32. Divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 1. I'm looking for groups of 3. So if we look at this here, we have this group that can go out, and we have this group that can go out. So if we multiply 2 times 2, we get this 4 here. So that's that 4. We can do the same thing with p. We have 4 p's, and we want them in groups of 3. So this can go out, so you get that p. That's where that p to the first is coming, and then this p that doesn't go out goes back into the radical sign. Same thing with the q's. So if I have 6 q's, I have a group here that can go out, and then there's another group here that can go out. So q times q is this q square that you have here, and then the p here is the only one that goes back into the radical sign. So the answer is 4p to the first power, q to the second power, and then it's the cube root of p.